In this lecture, we will discuss the magnetic force acting between two current carrying wires. In one of the last lectures, we have seen that whenever a current carrying wire is placed in a magnetic field, then the magnetic field produced around the current carrying wire and the external field interact, due to which a magnetic force acts on that wire, and that wire is either pushed one way or the other depending on the direction of the current and the magnetic field in which it is placed. Here we will determine the direction of the force acting between two wires which are carrying current. There is no external field in which this wire is placed. So the two wires may attract each other or they may repel each other depending on the direction of the current flowing in both the wires. In the figure you can see two current carrying wires, and you can also observe that the currents I1 in the wire 1 and I2 in the wire 2 are in the same direction. They are directed upward. First, let us consider this wire which is carrying the current I1, and the magnetic field produced due to this current I1 is B1, and its direction is counterclockwise. Now, how to determine the direction of the magnetic field B1? We will use the right hand rule. If we hold this wire in our right hand such that the thumb of our right hand indicates the direction of the current in this wire, then the curled fingers will give us the direction of the magnetic field B1 produced by this current I1 around this wire segment. So here the stretched thumb will indicate upward, that is along the direction of the current I1, and the curled fingers will give us the direction of B1, which in this case is counterclockwise. So the magnetic field B1 will be in form of rings centered around this wire, and the rings will have a counterclockwise direction. So if we consider one of these rings, here this ring is coming out of the page, and here it is entering into the page, out of the page and into the page. So if we indicate the direction of the field on both sides of this wire, we will put a dot over here and a cross over here. So let us indicate the field by a dot because it is out of the page on this side. And again, let us indicate the field by a cross over here on this side. So this one is the direction of here the field lines are coming out of the page, and here they are moving into the page. So that is why I have put dot over here and cross over here. Now come to the magnetic field produced by the current I2 in this wire segment, and that magnetic field is given by B2. And again we will use the right hand rule to determine the direction of B2 produced by I2. It will give us the same direction because the direction of the current I2 is the same as that of I1. So again, just as here on the left side the field was into the page, out of the page, and on the right side it was into the page, same will be the case over here. Here on the right side the field will be out of the page, and on the left side it would be out of the page, and on the right side it would be into the page for this counterclockwise magnetic field. So if you consider this area which is between the two wires, are the area where the two wires are facing each other. The field due to wire 1 is into the page, and the field due to the wire 2 is out of the page. That is, this field line is leaving the page and this is entering the page. So if I represent this cross where the field is entering the page, if we are denoted by the south pole and the other, this one, by the north pole. Here the field is leaving the page, so if I denote this dot by the north pole, let me represent it by the capital letter first. This one will be represented by the south pole and the other one will be represented by the north pole. So the unlike poles, they will attract each other. It means that the south pole of one wire is facing, the south pole of the wire 1 is facing the north pole of the wire 2. So the poles of the wires which are facing each other are opposite, and the opposite poles always attract each other. So the two wires will attract each other. It means that the two parallel currents always attract each other. If the case is reversed, that is, if one of the wire is carrying a current in the opposite direction, then what will happen? That is, if this wire carries the current in the downward direction, then the magnetic field of this wire will also be reversed, and here it will be coming, it will be going into the page over here and out of the page over here. So this side will become the south pole and this will become the north pole. So, and this is still the same. The case for this wire is still the same. So the south pole will then face the south pole, that is, the two like poles will be facing each other, and then the two wires will repel each other because the like poles repel each other. So the anti-parallel currents will repel each other. It means two parallel currents are the currents in the same direction attract each other, and two anti-parallel currents repel each other. This is the general rule for the magnetic force on two current carrying